All right, so welcome to the next lesson on conditionals and loops. So we use the term flow of control to refer to the sequence of statements that are executed in a program. All of the programs that we have examined to this point have a simple flow of control. These statements are executed one after the other in the order given. Most programs have more complicated structure where statements may or may not be executed depending on certain conditions or conditionals, or where groups of statements are executed multiple times, as in loops. If statements. Most computers require different actions for different inputs. Program flip, for example, uses an if-else statement to write the results of a coin flip. The table below summarizes some typical situations where you might need to use an if-else statement below. So working out if something is an absolute value, putting X and Y into sorted order, finding the maximum of X and Y, doing error check for remainder operation, and error check for quadratic formula. So let's maybe first look at the flip Y file. I do have it here in my folder, so let's have a look at flip this file over here. So what it does, it imports our standard IO library, which we are familiar with, and a random library. So that gives us random values. So what does this program do? It simulates a coin flip by writing heads or tails to standard output. So what is the format of writing conditionals is you have the keyword if, and then you have your condition, which you're checking. And this checks that random. We're using the library random. We're using built-in function random range, which just gives you a range of random variables between 0 and 2. And you're checking if that is equal to 0. Now, we've done this equal to 0 before in the previous lesson, where for Boolean operators, we check for true or false. And this is ultimately the output. We're checking if this is true. If the statement is true, then do this. And what does this do? It writes heads to your terminal output. Else, if that is not true, if it's false, then it writes standard either right line tails the output. And this is the standard, very standard, type of conditional you can expect. So let's try and run this. Let's try to run this in our library over here. So we can say run flip, and we get heads. So we can run this multiple times. Multiple times we will get different answers depending on random value that is given. So let's go through an example of that I had here. The most basic or fundamental conditional is, again, checking if a statement is true, if an expression is true or not. So if I can say, if true, and importantly, the statement, you ended with a colon, and then I say enter. And you notice very importantly that it is indented, because now we are in a code block. If the statement is true, there's a separate little piece of code that runs. So I can write to standard IO, standard IO dot write. This statement is true. Okay, let's enter. It obviously will say the statement is true because I'm forcing it to be true. So let me add a different. I can add to that, but I can also say I can add onto that. I can say backspace. I can say else. If it wasn't true, which obviously not the case, I can say else. Enter standard io.write. This is not true. Which is not the case because I'm forcing it to be always true. So let us take an example that they have here. One of these examples, and the easier one, finding the absolute value. If x is less than 0, then x is equal to minus x. So let's maybe try that one. So let's maybe store value x is equal to 5 over here, just for example. and a very basic conditional. I say if x is less than 0, then x is equal to minus x. And then we can print x. It's going to see what we get. Well, the statement was false, so maybe let's make our help us along, so understand what's going on, which is always useful to do, writing using right line statements wherever you can. This statement is true, else, and I will write this statement is false. Gives us a bit more understanding of how the code works. Again, this is one code block. This is why it's indented, why it has 4 spaces. After you have a colon, it automatically adds the 4 spaces. Let's run this code, Shift Enter. I only see the statement is false, and let's just do print right line. So I give this a new line each time. There you go. This statement is false. The answer is just 5 on its own. Let's maybe change this to -5. Now, x is indeed less than 0. It is -5. So it will say it will make it positive. And then it should say the statement is true. Let's run it. And it is true. So pretty much finding the absolute value. So you can try out these other examples, but this just shows you the basics of if statements themselves. So just to note that in Python, indentation is meaningful. For example, consider these 2 code fragments. If x is greater than 0, standard right line, not standard right line negative. So so these 2 will given. So this will. Let me try and copy it if I can over here. This is not really. I can just say if, tap it out rather, say if x is greater than equal to 0, enter standard either right, not and then add your backspace and say standard io.write align, say negative. So this is actually not correct. This needs to be within this code block. It needs to be indented as well. So 1, 2, 3, 4. So this will, do it together. So if I can run this code, say not negative, which is correct. If I, yeah, so this is important to note about code blocks when you have, conditionals or loops or anything else. So this is again what it should look like on the right-hand side. So if x is greater than or equal to 0, then both fragments write not negative. If x is less than 0, then the code left writes negative. So let's maybe test it out, what they're saying. So if I have, let's run this. Are we checking that? So let's make it 5. See, as you can note, I have to update this here first and then run this code. Let's check if that is, if x is changing. So let me maybe put this over here. So I am not affecting this code here. Not negative. There we go. That's what I wanted. So I forced x to be -5. It was actually being affected by this code. I made it -5. And then what it does, it checks in the expression, is x bigger than or equal to 0? It is not. So it will jump out of this and just say negative, which is incorrect. This is not where it's supposed to be. It should be here in this code block. So that's how it works. Obviously, it gives you nothing. If I run it again, it gives you nothing. So while statements, let's moving on. Many computations are inherently repetitive. The while statement enables us to perform a group of statements many times. This enables us to express lengthy computations without composing lots of code. He programs 10 hellos, writes hello world 10 times. Let's have a look. 10 hellos. So import our library, and we're just writing 1, 2, 3 hellos, which is pretty straightforward. But what the while loop, how it is constructed is you need a few things for a while loop. I'm going to maybe copy this outside over here so we can test it out. Well, let's first run the code and we can get an example. So let's run 10 hellos just to see output we get. I'm going to percent run 10 hellos. And we get lots of hellos. Okay, so how does it actually work? Because it's really important to understand what they did here. So let's maybe just copy this part over here, and we need to import our library as well. Import standard IO. Okay, I think that should be fine. She should do this. Maybe add a cell. Okay, I wanted. Okay, so what is actually happening here? Well, with any while loop, when you have a loop, you need a few things. So a while loop, a while loop needs starting point, a condition, and an iterator. So these are the three things it effectively needs. So in this code, what is what is? So our starting point is I equals 4. A condition, well, it's while I is less than or equal to 10. This is our condition. And then our iterator is I equals I plus 1. So these are the three things you need for any while loop. This code is what you would run in your code block. So this can be anything, depending on what you want to do. But effectively, these are the three things. Then we can change it and modify it however we want. So what does it do? Well, it says, okay, well, I'm going to start my loop, my iteration from 4, because we already have 3 hellos, plus hellos. And I'm going to check, is I, which is currently 4, is that less than or equal to 10? Yes, this statement is true. And if it's true, do this code block. Do not exit the loop. Do not go to the next line. So the next line might be here. So standard IO, right. The next line. So do not go to this line until this is done when this condition is met. So this condition is not met yet. So it's still true. When it becomes false, it will exit this code block and jump to this line over here and do the rest of the code. So what does this do? It checks I is less than or equal to 10. It says, okay, well, that's true. So I write, right line, and I write the value I, which is currently 4. I convert that to a string, and I say plus, I concatenate with th hello. This is what you see here. This is effectively what's been written there. After that, we have our iterator.